Hello. 2.3, analyzing graphs and functions. Okay, first, I should have had a space there. Sorry. So looking at this graph right here, we're looking first at the domain. Domain is what can your x values be, or x values. So if I look at my domain left to right here, my x value starts at this point right here at -1, and it goes until this point at 5. But look at how I'm starting and ending differently. So at 1, that's enclosed because I can be, sorry, at -1, that's closed because I can be that number. However, to 5, I cannot be that number, so that's going to be a parenthesis. B, the function values at -1. So if I go to -1, what's my y value? So the function at -1, my value would be 1. So if I were to evaluate -1, my answer would be 1. If I were to evaluate 2, so if I look at 2, when x is 2, y is equal to -3. That would be -3. That's my input. That's my output. And lastly, what's my range? My range is my y values. So how low does this go? How low does it go? So my lowest y value is -3, and the highest that it goes is 3. It's including both of those, so I'm going to have a bracket for both of those. Now let's look at that vertical line test. So what if we want to say, is this a function or not? Well, we can do our vertical line test. Now, when you're looking at a graph, you should assume that this is going on forever, unless if there's a point that stops it. Otherwise, this is going on forever. Here's going on forever. The reason why we have that vertical line test is because to make a function, that means the x can't repeat. So this right here is a no because this x right here repeats. So this is no, not a function. Again, you can always test more than one vertical line. This would be yes, this is a function because the x only hits one spot, the x. Now, sometimes people get confused by this. Now, if I did a vertical line here, it only hits one spot, What if I don't hit a spot at all? That still is a function. Yes, this is a function. Yes, this is a function. This is just saying that it's undefined in between these points. A function can be undefined at a certain area, or it's not in its domain or range. But yes is a function because of the vertical line test. So example 3, finding the zeros of a function. Now we've actually already been doing this. The zeros of a function are where it crosses the x-axis. Where it crosses the x-axis, that means this is equal to 0. And we've already been preparing for this problem because I can factor this. So numbers in between, so two numbers that multiply to get 3 would be, the only option is 3 and 1. So I have to find a pattern with 10. So -10, 2, and 5 probably. I'm going to try the -5 here, the +2 here. So I check this. This right here gives me a +6. This gives me a -5. So this factors out because together they add up to 1. And I set each one equal to 0. So if I solve both of those equal to 0, I get that my zeros of my function would be a +5/3 and a -2. So for the second one, where it crosses the 0. So undo something, the square root, you're going to square it. Well, squaring 0 is still going to be 0. So I subtract the 10 over. Sorry, this is still 0. Subtract the 10 over, I get -x² is equal to -10. Divide by the negative. Now I can take the square root because I'm dividing by that negative. So x would be equal to, remember here you're going to have a positive negative number because when you have a squared unknown, you always have two different answers. Now this one's a little bit trickier. I can still solve this equal to 0. So I would get rid of this division first. So I'd multiply this t plus 5 over, well, 0 times anything is going to be 0. So actually, when we're dealing with a fraction, I really only care about when the top of the fraction is equal to 0 because the bottom will make it undefined. So I'm looking at just the top. So I add the 3 over, divide by 2, and I get my zeros at 3/2. Now, especially with a fraction and a root, you want to see if you plugged it back in, if it would make it possible. So 3/2 does make this possible because I do not have a negative on the bottom. So now we're getting into when graphs are increasing, decreasing, and I forgot a constant. So when you're looking at a graph, it's like if you were to be on top of a graph, are you going up or down? So let's say if I drew this picture right here, okay? And let's put some numbers on that. If I were to follow this, it looks like I'm going down here. So if I'm going down here, this would be decreasing. And because of these points here, I would be decreasing from -1 to 0. So I'm, decreasing from -1, and it's including -1 to 0. That's where I'm decreasing, where I'm going down. This is a constant. It's not moving up or down. That's a straight line. So from 0 to 2, I would be a constant. And if I'm going up here, so again, when I'm tracing this out, if I want to know if I'm increasing or decreasing, the best way is to trace out with your pen or pencil from 2 to 3. So when you're looking, if I'm moving down, that's decreasing. If there's no change, it's a constant. If I'm going up, it's increasing. I want you to pause the video and try to do this one by yourself. So when I'm looking at this, I'm going to use just parentheses. We don't have to use a closed circle, open circle at this moment. So this one might be more confusing because I'm going up, and people sometimes think that this is a constant, but it's ever so slightly still moving. So if you question it, you can ask, but it's just that it's moving so slowly that it is slowly increasing still. So this is actually increasing from -infinity to infinity. So here I'm going up, so I'm increasing from -infinity to -1. Notice how it's always the x value. Then I'm going down from -1 to 1. So that's decreasing. And I also have more increasing from 1 until infinity. Here I'm going up -infinity to 0, and then this is a constant from 0 to 2, and then I'm going down from 2 until infinity. So relative min, relative max. So this is kind of like the highest point, roughly the highest point, roughly the lowest point. So what I have, I'm going to look at this point right here. Because this is the highest, we went from increasing to decreasing. It's like a hill. This right here would be my relative maximum, my relative maximum, because I'm going up and then down. This point, this is like a valley. I'm going down then up. This would be a relative max. Now, when we say relative min and relative max, we say the whole point. It's not just the x or y. Sometimes people just say the y, but we're going to say the whole point. So let's say we have this. Oh, there should have been a space. I want to determine the relative minimum here. First thing I'm going to do is graph this. So I go to my y equals, put it in. I'm going to go to the graph. I'm kind of zoomed out. I'm going to go to my zoom. Oopsies. I'm going to go to zoom. Come on, zoom. And I'm going to go to zoom standard, which would be 6. So if I push 6. So now I'm on a 10 by 10 grid. I'm looking for my relative minimum. It's already telling me I'm looking for minimum. So I'm looking for this point right here. So I'm going to use my calculator to get that point. Go to calc. I have to push my second key, trace, and I want that minimum. So I'm going to go to 3, or else you can arrow down and then push enter. Reading my directions here, it says left bound. Here is my point. I have to get my bug on the left-hand side, push enter. Now it says right bound. So here's the point I'm looking for. But right bound means I have to move over someplace on the right and push enter. These should always be pointing towards each other. So the point you are looking for should be in between those two lines. Now it's saying try to guess that point. If I try to guess that point, it would be right here. And then it gives us the actual minimum. Do you see that? So this would be about 0.667, comma, -3.333. However, because I know decimal points pretty well, that's the same thing as 2/3 and -3 1/3. Now, average rate of change. Now, it's the same type of thing that we have had for the average rate of change. This is your difference of y over your difference of x. However, when we do an average rate of change, that's a linear model. So when you have a picture like this, we go back to this one, and we want to know what the average rate of change in between these 2 points, we are estimating it. It's basically like saying, what if there was a straight line to those 2 points? This is called a secant line. This is the secant line when we're dealing with a non-linear model trying to force a linear model in between 2 points. So again, this is still my difference of y's over my differences of x's. So if I need to figure out what my rate of change is, so this first one that's saying my x1 and my x2, I actually have to figure out my y is. So say my x1 is -1, I have to figure out my y, my x2 is -2. I have to figure out my y. So if I plug -1 into this equation, what would I get out? I would get 2 out, and if I plug -2 in, I would get -2 out. So again, all I did was plug that into my equation right here. Plug -1 in here, and here, I got 2 out, plug -2 in here, and here I got -2 out. when I'm looking at my rate of change for these 2 points, it's my difference of y's. So difference of y's means 2 minus -2, because that's right here. And then -1, since I have that 2 first, -1 minus a -2. And I simplify this. This becomes plus, 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 plus. This becomes 4 over 1. So my slope secant, so again, this is when it's a nonlinear function, but finding the average rate of change in between those 2 points is going to be 4. I want you to pause the video and try to do this one by yourself. So my slope secant is at -2. So if I look at example 7, it says the distance in feet of a moving car between a stoplight is the given function of this. So here's my function, just like how this up here was my function. It says where is the time in seconds where t is equal to seconds? Find the average speed of the car from t1 to t2. So this is exactly what we just did, except in a format with words. So if I were to find my 2 points, if I plug 0 into the equation, if I plug 4 into the equation, what do I get out? If I plug 0 into that, I just get 0. If I plug 4 into this, I do 4 raised to the 3/2 power times 20, and I would get 160 out. So again, my difference of y's over my difference of x's, I would get 40. Now in this case, this would be feet per second, because it's telling us that we were going feet in seconds. Pause the video and try to do B by yourself right now. So we get 76 feet per second. Okay, odd even function. So if we have an even function, this is true, is if we plug -x into the equation and we get the original function out. That means it's even. If we plug -x into the equation and we get the negative of that function out, then that is odd. So let's test this. So both of them are plugging in -x into the equation. So if I plug -x into this equation right here, I would get that this is 5 plus 3x. Now this is definitely not the same. Now let's see if we can take out a negative to see if it is odd. If I take out a negative, this becomes a -5x minus 3x. Is this the same as the original? No, it is not. So this is neither odd or even. This one's neither of them. Neither odd nor even. So let's check this one. If I plug -x into the equation, now this should be kind of review from when we did this in chapter 1. This would be -1 to the 4th. That would give me x to the 4th. This is -1 squared. That still gives me x squared. So because this is the same as the original, this would be an even function. So I want you to pause the video and try to do this last one by yourself. So we plug this in, -1 cubed is still going to be giving me a -1. -1 times 3, that gives me negative. Now I'm going to try to force that negative out. Now when I force out this negative, this is the same as the original. So because this is -1 times the original, this is an odd function. That's all I have for you today. Have a wonderful day.